Hi everyone. Thank you for joining. Today we're going to present to you a new feature in Amazon GuardDuty that enhances our threat detection for Amazon EKS, Elastic Kubernetes Service clusters and workloads. I'll start by introducing ourselves. My name is Amit Megiddo, Principal Product Manager, leading product management for Amazon GuardDuty over the past 5 years. And I have here Wasik with me.
Hi, everyone. Thanks for joining. My name is Mohammad Wasif. I'm a principal security engineer with Amazon GuardDuty. I have been working with GuardDuty for 5 years now, and my main focus is to do research and development for improving the detection capabilities of GuardDuty.
Thanks, Wasik. We'll start with just quick background on overview of Amazon GuardDuty to set the stage before we dive into these new capabilities related to EKS. Amazon GuardDuty is a threat detection service that is used by tens of thousands of AWS customers, including over 90% of our top 2,000 customers, to help protect their AWS accounts, workloads, data, the general AWS environment. It's a big data processing. We collect a lot of or access a lot of different log sources and run different analytics on them, such as machine learning, threat intelligence, and other heuristic-based detections to identify highly suspicious, potential malicious activity in the account, in the environment that indicates a threat to your AWS environment and alert you on it to help you be better protected. And it was 5 years. We launched over 5 years ago, and as I mentioned, we have a lot of customers that help us get also a lot of feedback back to the service. And over these past 5 years, we've been using that to iterate a lot on the capabilities, improve the detections, expand our coverage, and help our customers better protect their AWS environment. Few key points about GuardDuty and how we designed it and continue to iterate on it to help our customers. So first of all, here on this single-click organization-wide, this is important. A big focus for security should be to make it simple for customers. And that really helps ensure that the environment is better secured. It avoids gaps and drifts and different things that could cause blind spots. And so we really designed GuardDuty to be super easy to turn on. You can quite literally turn it on with a single click in the AWS console, and it immediately begins monitoring your environment for threats. And not only is that single click applicable or clickable if you're working in a single account, but even if you're working in a big enterprise, managing an organization with thousands of accounts, almost a single click, you can enable the service across these thousands of accounts, and including any new account that joins the organization, and automatically have GuardDuty monitor that account for threats as well. Once GuardDuty is enabled, we start to continuously monitor the environment and all resources in it. That means that you don't have to start configuring specific resources or specific instances or S3 buckets or RDS databases that you want to have protected, but we continuously identify all new resources and the related logs from them and protect them automatically. So again, removing that complexity, that configuration, that adds overhead and can lead to potential gaps in security. We have a lot of different detection methods that we use and we continue to develop. We launched GuardDuty with around 30 detections. We're well past 120 now, different detection capabilities in GuardDuty. And two big areas of focus have been ML and threat intelligence. So on the ML side, machine learning, we have here teams of data scientists, applied scientists, machine learning experts that sit together with security experts, such as Wasik that we have here today, to really work in developing different detection capabilities and continuously iterating on them as well after we launch new detections, with the goal of making them as accurate as possible, meaning if there's bad stuff going on in the environment that we detect it, but maybe as important also is that if there isn't any bad stuff going on in the environment, we don't generate alerts that can lead to alert fatigue and ultimately perhaps even for alerts being ignored if there's too much noise in the environment, and in which case also the true positives may be missed. So we really focus on both ends. How do we get the detections to a point where we identify the bad stuff, but do so with very little noise around that? And some of the ML techniques we've been able to research and develop over the past years have proven to really do that well. On the threat intelligence side, so this is when there is an indicator of a known bad. It could be an IP address, it could be a domain name, it could be a file that we know is bad, and we use different sources for that. We're integrated with third-party threat intelligence feeds that come built into the service when you enable it. But also we develop a lot of our own threat intelligence here in AWS, where we can leverage our broad visibility and customer feedback to really develop threat intelligence that's highly tailored to the AWS threat landscape and results in accurate detection. And finally, we started off with that enabling with a single click across an entire organization, and the other end also the enterprise scale of this, of then also being able to manage it at the organization level. And again, if you have hundreds or thousands of AWS accounts, you can manage everything from a single GuardDuty account and see all the alerts and all the findings from that single pane of glass. Going just one level deeper into how all of this works behind the scenes. So we mentioned the different log sources that GuardDuty consumes. This has been a big area of focus and development. What other telemetry and visibility can we add to GuardDuty to help protect the environment? When we launched GuardDuty, as mentioned, over 5 years ago, we had coverage for the VPC flow logs, DNS logs, and the CloudTrail events that we see here. We've since added more visibility, and as we'll discuss today, we're going to update on the latest one added. So the flow logs and the DNS logs, those help protect the compute workloads, the EC2 instances in the environment, looking at all the IP connections they make, all the DNS requests from all the EC2 instances in the account. The login events, that is the latest addition before the one we're talking about today. In fact, launched it earlier this month in March. And that monitors all login events to Amazon RDS Aurora databases and uses machine learning to detect highly suspicious and potentially malicious access to your data stored in Aurora databases. So obviously big area of focus, data protection and databases, and we're happy to have that added in GuardDuty recently as well. The CloudTrail events, that's in many ways the bread and butter of security on AWS are the CloudTrail events, looking at all the API activity across the environment, and gives it really a very rich log source, a contextual log source of activity in the account, in the environment, across practically all AWS services. And we use that extensively in a lot of our detections. The first log source that we added post GA, this happened in July of 2020, was expanding to look beyond the CloudTrail events on the control plane side to also look at the data plane events specific to S3 buckets. So this looks at all the API interaction with objects in the buckets themselves, listing the objects, retrieving, getting the objects, deleting the objects. And obviously, again, with our focus on helping customers secure their data, this provides a very good visibility that allows us to detect malicious or highly anomalous access to data stored in S3. And then a good segue into what we'll talk about today is the EKS control plane logs, or the Kubernetes audit logs from EKS clusters. We added this just over a year ago, which is part of our big focus on container security, with the broad and accelerating adoption of containers and the big focus there. It's a big area of focus for us also from a security standpoint. So last year we added the visibility to the EKS audit logs, which a lot of our customers are using to help protect their EKS clusters, and has proven itself to be a very good log source to detect EKS threats. All those log sources are pushed into the heart of GuardDuty, which is our security analytics. And then that's what matters, like the quality of analytics that we can run on these log sources. And this is where the different methods that I mentioned before, machine learning, threat intelligence, as well as not only monitoring all of these events and logs to detect threats, but also to, in the background, continuously learn and profile and build profiles of the environment, of the resource in it, of the users and IAM identities in the environment, so that we can have that baseline of what is expected for the environment. And the next time we see an event, be it a VPC flow log or an RDS login event, and etc., we have that historical profile, and GuardDuty can determine whether that was expected behavior or not. And now at the other end come the security findings. So these are alerts in the environment, and we, as mentioned, really focus on enriching them with all the relevant context and information that will make them actionable. Again, we're very we hear our customers, we're aware of pain points in this field of too many alerts and non-actionable alerts and alert fatigue. So we're really doubling down on it for years now, of helping making these alerts actionable, providing as much contextual information about the threat, about what was expected for the environment and what was different this time, and presenting that to customers. The alerts can be viewed in the GuardDuty console, and a lot of customers do that. But also, and then these are JSON files with all the details in them. And they can be easily integrated with downstream AWS or non-AWS services. And we also see a lot of customers use that, especially in large environments where there could be hundreds or thousands of accounts, and pushing all of these alerts and findings into ticketing, alerting, SIM solutions, or other AWS security services, such as Detective for investigation, Security Hub for investigation and response. Security Hub for consolidation across the different detections, and EventBridge, where they can then be pushed into the many integrations with our partner solutions. A big value proposition here, and it's something that really resonates with customers, is the fact that for all these log sources that we see here today, the flow logs, DNS, RDS login, CloudTrail, S3 data plane, EKS control, all of these log sources, you don't actually need to configure them individually in your account or in your environment, or collect them or incur any costs related to collecting these events in order for GuardDuty to work. We do all that on the back end. The moment you enable GuardDuty, we start consuming all of these log sources automatically on your behalf, without any changes required in the environment. There are some areas where customers are and should be collecting these logs, such as CloudTrail is definitely recommended. But in other areas, the S3 data plane, the flow logs, and in other areas, the amounts of data are so large that it's often not really reasonable for customers to be collecting these across the entire environment for every single log. And GuardDuty does that for you automatically without you having to do that yourself. So now we're very happy to introduce the recent launch of Amazon GuardDuty EKS runtime monitoring. And this is really, again, as I mentioned, doubling down on this area of container security, starting here with EKS, that we hear from so many customers, the importance and the gaps that exist today in the space. And we think this is going to really help a lot of customers deal with that. So going beyond the Kubernetes control plane that we added last year of that visibility to EKS, we're going now to the deepest level of visibility you can have into containers and looking at their runtime activities. So this is, for example, file access, process executions, network connections. And doing this was, for the first time in GuardDuty, adding on-host visibility was a GuardDuty security agent that was designed to be lightweight and efficient to allow the monitoring of these containers at runtime and get that level of visibility. Very important. This is the first time that we're going from GuardDuty getting that backend access to the logs to an actual agent that's running on the workloads in your environment. And we wanted to make sure that while we do that and we take that important step, we don't compromise on the things that have made GuardDuty so successful and that we hear from customers that they love about the service, and that's the ease of use and that single click experience. So we worked very closely with the EKS team, with the Container Services organization here in AWS, to integrate very tightly between the services and to be able to keep that delighting GuardDuty experience even when we go into this level of runtime visibility. So with GuardDuty now in EKS, we can maintain that single-click experience now to also begin monitoring all of your EKS clusters across an account or across an entire organization with just a few simple steps in the console. And this is something that we'll also demo in a bit and show how that works. And then this new visibility comes also with new threat detections and finding types. I mentioned we're over 120 now, so this is, again, pushing that even forward with more detections that are tailored for container threats and tailored for the type of events that we can now have visibility to through the agent. Taking a step back, this is part of the broader EKS, in general, container security offering that we have now. So combined with looking at the EKS control plane or the general AWS control plane through CloudTrail, where GuardDuty monitors all of the cluster configurations, the creation of clusters, etc., through the EKS APIs. Those are monitored by GuardDuty with advanced machine learning capabilities and threat intelligence. We go one level deeper, looking at the Kubernetes control plane, leveraging those auto logs, as mentioned before. And now, jumping over the nodes, I'll get back to in a moment, we're going even deeper, looking into the containers at runtime. Now taking that step back to the EC2 nodes, in GuardDuty today, as I mentioned, we monitor the VPC flow logs and DNS requests coming from EC2 instances. That was one of the pain points customers had related to EKS, is that GuardDuty would generate an alert for an EKS node that is potentially compromised. And for example, saying, alerting you that this EKS node is communicating with a malware command and control server on the internet based on the IP connections you see it make. But previously, just looking at the flow logs in DNS, GuardDuty wasn't able to pinpoint the specific resource or container or pod and provide that level of detail. And now with the runtime visibility, we are able to do that, and we'll show that as well in the demo. Now, I think an interesting value proposition coming out of this is that we also will still continue to monitor the flow logs and DNS requests at the node level as well. And that's really allows us, when we're using the agent, if there are cases where there's agent failure or potential malicious actors tampering with the agent to evade detection, GuardDuty will continue monitoring the flow logs and DNS, which, as mentioned, happens completely out of band of your environment, directly on the backend integrations here within AWS, which means even if that in those cases, you'll still get some signal and some indication that there's the potential compromise of the container, even if you don't have that runtime visibility. Now, we also hear from customers on the other end that these flow logs in their large volumes that are contributing to the GuardDuty bill. So the way we're going to manage this is that if you enable EKS runtime monitoring and the agent is active on the workload, we'll continue processing the VPC flow logs for you and alerting you on the alerts related from these flow logs, even if the agent fails, but you won't be charged for them. So that, I think, is another interesting value that we can provide here. I'll really skim over this because we're going to demo, and the demo would be much cooler than a screenshot. But really, as I mentioned, the easy steps to enable this organization wide, even though we're dealing now with agent deployments in the environment and really focusing on that. And then also, as mentioned, there could be issues with agent tampering or other issues related to resulting in coverage gaps of EKS runtime monitoring. So we're also going to give you, in GuardDuty, a complete view of all clusters in your environment, which ones are protected by GuardDuty, which ones are not, why are they not, help you troubleshoot that, and make sure you get to that point of the desired 100% coverage. And then also giving you the tools needed to make sure that coverage is maintained. So you don't have to go back to the console every time to make sure you stay at that 100%. But we're going to send push notifications through EventBridge that you can automate or integrate with your ticketing or alerting systems, or an SNS email to email and just be alerted if there's any change or degradation in coverage that you can then quickly troubleshoot and resolve. And we've really designed this and tested this in many different environments to make sure that that 100% is what you usually will see here and should see here when you enable this for the first time. But the goal here is to help you make sure that that is the case and to maintain that 100% coverage going forward. With that, I'll pass it on to Wasik that will talk a bit about the new visibility and findings.
So thank you, Amit, for introducing the new EKS runtime monitoring that we are launching with GuardDuty. One of the main reasons why we invested in runtime monitoring based on an on-host agent is that lots of our customers they now run containerized workloads, and one of their main demands is that the detection should be container aware. In other words, the detection should contain the container level information. And our existing VPC flow log based and DNS logs based detections, they do not contain container level information. So that's why they are not very actionable for our customers who are running containerized workloads. So we built that agent. We have built this agent based on eBPF, Linux eBPF technology. It sits inside the eBPF part, sits inside the kernel, and it observes the activity of various processes inside the kernel. And then we also have visibility inside the user space, and we are able to collect a, a rich set of context from both inside the kernel as well as the user space. So we are able to get things like process details, like the executable path of the process, ID of the process, the details about the parent process, and so on from inside the kernel. And then we are also able to get details about the containers, such as the container IDs and container images, and so on. So with EKS runtime monitoring, this is what we are going to get that you see on the left side. So as you can see, not we are not able to just provide the EC2 instance level details, but we can also provide container level details, pod level details, and also process level details. This is a significant improvement um, on top of our existing EC2 based detections, which are only able to provide EC2 level context. So here are the specific fields. Some of them, the main fields that will be able to provide in these EKS runtime monitoring findings. So these are the additional areas or additional context that we'll be able to provide. First of all, as far as the container details is concerned, the findings will contain the container ID, container image, the full path of the container image, or full URL of the container image, which was used to launch the container, and container name as well. For Kubernetes pod level details, will provide you the pod ID, pod name, and also pod namespace. And then we'll also provide you the process level details. Some of the main things that we'll provide for processes will be process ID, the executable path or the absolute path of the process is executable, the ID of the parent, SHA-256 hash of the process executable, which is very important. So you'll be able to search for the process on various malware databases using its SHA-256 hash, such as VirusTotal. We'll also provide the user ID, effective user ID. And another interesting thing that we are able to provide is process lineage, which basically gives you, uh, you know, provide you all the ancestors of the process, starting from the immediate parent to the grandparent and so on. So a little bit about the high level architecture of the overall service, the end-to-end service. So, so we have the agent part, which runs on EKS nodes or EC2 instances. And then the other part, main part, is the backend, which runs on the GuardDuty backend side. So the agent simply collects and sends events from the node, and it sends those events to GuardDuty backend through a GuardDuty endpoint, which is exposed as a VPC endpoint. And it sits inside your VPC where your cluster is. Uh, GuardDuty backend collects the events from the agent, and then it applies threat intel uh, on those events in order to identify any um, connections with known bad IP addresses or known bad domains. And then it also applies a set of stateless rules, right? So these are the rules which depend on just a single event. In addition to that, we also have stateful rules which depend on or which utilize two or more events. And then like all other data sources that GuardDuty currently consumes, such as CloudTrail logs and flow logs, we also apply machine learning based intelligence to these runtime logs as well. So all these backend capabilities allow us to provide valuable detections to customers, and they will allow us to provide more and more value in future. So these are the detections that we currently have at the time of the general availability of this service. So we'll have all the threat intel based detections that we currently have for VPC flow logs and DNS logs based detections in GuardDuty. So we have IP based detections. So these detections alert you when the node or a container on your EKS node connects to a known bad IP address. So you can get any of these detections. So for example, if a node connects to an IP address which is a known crypto mining server, uh, you are going to get the alert, this Bitcoin tool.b alert. And then we also have DNS based detections. So these will be triggered if your container connects to or looks up a known bad domain name, which is on our threat intel. The main difference from between these detections in EKS runtime protection and our existing EC2 detections is that these detections are going to provide, as we covered earlier, much more context. In addition to threat intel based detections, we are also launching with uh, container specific detections. So container drift is um, container drift is another feature that we can detect, which is very useful in context of containers. So containers are it's a best practice to use containers as immutable compute resources at runtime, which means that the containers should not be modified or should not be updated, or you should not download or create a new binary or a script at runtime inside a container. So so typically when it happens in a container, it could be an indication of is something suspicious happening. So that's why we have these three findings which indicate or which cover container drift detections. And then we have detections for container escapes as well. There are certain things, there are certain common attacks which could be used for escaping out of containers. So we have detections to cover those. So other than that, um, we have several detections for alerting on suspicious process behavior. So for example, if a process on inside your container or on your host tries to create a reverse shell back to a CNC server, we have a detection for that. And if let's say if a container um, inside your EKS cluster tries to execute a crypto miner, we have a detection for that based on process execution events. And then we also have detections for common techniques which are typically used for defense evasion. So for example, fileless execution and the use of user fault FD system call on Linux. Okay, so this was some low level introduction about what we are launching as part of EKS runtime monitoring. Now we are going to have uh, a demo where we are going to show how this feature can be enabled and what type of directions you can expect. So in our first demo, we are going to show how it can be enabled, and it could be enabled using AWS organizations as well. Um, so here I have my account, my AWS account, and it is part of Amit's organization, who is the other presenter. What we are going to show that right now EKS protection is not, EKS runtime monitoring is not enabled on my account at this moment. Amit will go ahead and enable it at the organization level, and then we'll be able to show that the EKS protection or EKS runtime monitoring is enabled in my account as well, which is a member of Amit's organization. So here on the screen, I'm showing my EKS cluster, and just a brief introduction about how we are provisioning the new agent. We'll be deploying the agent as a daemon set on Kubernetes clusters or EKS clusters, and it will be deployed as an EKS add-on. So we have a new EKS add-on which will be added to your cluster once you enable EKS runtime protection. So here, if I go to the add-ons tab on of my EKS cluster, at this moment you can see that there is no add-on here. There's no Amazon GuardDuty add-on. Once Amazon GuardDuty EKS monitoring is enabled by Amit, that add-on is going to appear automatically in my account. So Amit, please go ahead and enable it at the org level.
Gladly. Yeah, so now you can see I'm here in my GuardDuty account, as Wasik mentioned. I'm a delegated GuardDuty administrator for this organization. I go here to the EKS protection settings in the GuardDuty console. You can see I already enabled this for my individual account, for this delegated administrator account. And now I'm also going to enable this for all of my members. We saw I have 17 member accounts. None of them have EKS protection enabled. So when I click here, edit, and now I see I have several options here of how to configure EKS protection, with the default option being the recommended setting for the organization, which is to enable both EKS audit log monitoring, the runtime monitoring, as well as the manage agent automatically set, which will result in the agent being deployed on all existing and new EKS clusters in all accounts in the organization, including any new account that joins the organization. Now, as we saw here, I already enabled this for myself, for the delegated administrator. So I spent some time setting up a test EKS environment, testing this out, making sure that I understand how the agent works on the workload. And now that I feel comfortable with enabling it for all of my workloads across the organization, this is when now I'm proceeding to enable it at the organization level. So easy, save these configurations. As we see here, as we mentioned, very clearly stated that this will result in GuardDuty deploying and updating the agent for all existing and new EKS clusters, as well as enabling the audit log coverage. I save it here. And now we can see that all 17 accounts are enabled. You can also see that this also any new account that joins the organization will automatically have the same settings. We saw here how I configured this at the organization level. I can also go to my accounts page where I see all of my members, and I can choose a specific member or several members, and through the action here also configure this individually for an individual account level. And again, this may be useful maybe initially to choose one or two accounts, test accounts where you want to test the agent deployment and performance out, and then after uh, doing that, coming back here and enabling it easily at the organization level. Now, in addition to this configuration option that I chose to manage the agents automatically, I can also uncheck this box, in which case EKS runtime monitoring will still be enabled for the account, which means that if there is an agent deployed, then GuardDuty will receive and process and analyze events from the agent, runtime events for threats. But now it's up to me to deploy the agent or enable the EKS manage add-on, which can be done at an individual cluster level, whereas from GuardDuty it's managed at the account level, all clusters in the account. But you can also just go to the EKS console page, add-on settings, and add the GuardDuty EKS runtime monitoring add-on individually to a cluster. In addition to the add-on, there's one more thing that happens when I choose manage agents automatically, which is that GuardDuty also creates a VPC endpoint in VPCs where the EKS clusters are running. And again, if I uncheck this and I decide I want to manage this manually at the cluster level, I also have to make sure that I create the VPC endpoint that is required for GuardDuty to deliver the events to GuardDuty. And all of this can be shared in the resources and user guide with step by step of how to do all of that. With that, I think we can, Wasik, you can take back over and show us that the add-on has been added to your cluster.
Thank you, Amit, for enabling EKS monitoring in my account. And here I'm again showing clusters details. And if I go to the add-ons tab now, I can see that Amazon GuardDuty EKS runtime monitoring add-on is enabled and added to my cluster. So now my cluster is protected by EKS runtime monitoring. So this shows that how easily you can enable runtime monitoring at org level at a single click of a button from the admin account. So now let's move on to the second part of our demo. In this demo, we are going to show what type of detections you can expect, or what type of detections you are going to get through EKS runtime monitoring, and what type of attacks can trigger those detections. So imagine a scenario that I leaked credentials of my Kubernetes cluster into source code, and I published that source code on GitHub. An attacker was able to compromise or steal those credentials from GitHub. Now they have credentials of my Kubernetes cluster, and they can use those credentials to do various things on my clusters. So for example, they can connect to the API server of my Kubernetes cluster. They can launch new pods. They can exec into or connect into the pods that are running on my Kubernetes cluster. So so here I'm going to show a scenario where the attacker connects to one of my pod using kubectl, and then they download a crypto miner on my pod and execute that crypto miner inside my pod. So here I'm using kubectl to simulate the attacker connecting to one of my pods. So as you can see, they are now inside my pod. Now the attacker is going to download a crypto miner inside my pod. So the attacker is using wget to download a crypto miner. They downloaded the crypto miner, then they added executable permissions to it. And then now they are going to execute it. And the attacker now executes the crypto miner. So they have downloaded a binary inside a container, and then they executed crypto miner, and that binary was a crypto miner, and then they executed it. So we should see multiple findings in GuardDuty now because of this activity. Let's go to the GuardDuty console here and check out if we have already received some findings. Let me refresh. Yeah, so as you can see, we have already got a new binary executed finding and a Bitcoin tool.b finding. So these are the two findings which are triggered, due to this activity which the attacker performed in my pod. So I'll first show you the Bitcoin tool finding, which is based on threat intel. So this happened because when attacker started crypto mining, they connected to a mining pool domain name, and that domain name is in our threat intel. So that's why we generated this finding. It is similar to the same EC2 level finding that we already have. But the main difference here is that in this finding, we are providing a lot more context. So you can see that we have EKS cluster details, and then we have Kubernetes workload details, which means the Kubernetes pod, because workload is a pod in this case. So we have the name of the pod, we have the namespace of the pod, we have UID of the pod. And then we also have container level details. You can see that the container runtime is Docker. And then we have the ID of the pod, we have name of the pod. We also have the complete image of the pod. And if I go further down, then you can see that we have process level details as well. So you can see the complete executable path of the process, the SHA-256 hash of the process that you can grab from here and search on websites like VirusTotal in order to see if it's a known malware or not. We have the process ID, we have namespace process ID as well as the host level process ID. So namespace process ID is a process ID of a process inside a container. But host level process ID, which is just process ID here, is the host level process ID which the host sees. All right. And another interesting thing here is the lineage. So which is which shows the complete lineage of this process or all the ancestors of the process. So here you can see the parent, the direct parent of the process here, which is of course bash because because the attacker executed the miner from a shell. And then you have the grandparent here as well, which is container dshim, which basically means that this is the original process inside the container, or the init process inside the container, right? And then you have uh, the last process, or the topmost process in the tree, which is of course always system D in case of Linux. And you can see that the process ID is 1. So here we are demonstrating that we are able to show the complete process tree of the process. And this is a very important capability because this allows you to um, trace the lineage of the process, trace the complete end-to-end activity of the process. And it is also important in case of service or application compromises. So imagine you have a web application which was compromised, and the attacker was able to gain, let's say, shell access using that compromise in a web application. And then after gaining the shell access, they performed various suspicious activity which was detected by GuardDuty. Now, by having this lineage, you will be able to trace back and figure out, that there was a web application somewhere in the lineage, right? And that will show you that maybe that it was a compromise of that web application that originated this attack. So that's the importance of lineage. Now that was the first finding. The second finding is new binary executed. Which I'm going to show here. Yeah, this is interesting. As you saw during the attack, the attacker downloaded the crypto miner inside a container, so which is basically which represents a container drift. So basically, container drift happened, um, and then we have a detection for that. And later on, after downloading the binary, the attacker also executed it. So that's why we generated a new binary executed finding here. So here again, you can see that you have all the context information, which includes pod level details. And then you also have the container level details, you know, as I show you in the previous finding as well. Now, again, you also get the process level details here. So again, the process which was executed as a new binary, is again the miner. And again, you can see the complete lineage of that process. Now, let's say the credentials which the attacker compromised, they are ephemeral or temporary credentials. So they might want to persist, some way of persistence. And in order to, let's say that in order to persist themselves on the node or inside the pod, they created a reverse shell. Persist and connect to a command and control server so that they can perform or send various commands over time to the pod. So let's imagine that they created a reverse shell. Here I'm going to demonstrate a reverse shell. So I'm still simulating that the attacker is executing a reverse shell. I have this a script, pre-written a script, which creates a reverse shell. Let's go back to GuardDuty console, and we should see a reverse shell finding coming up in a minute.
Wasik, while we wait for it, I think an important value here, interesting, is that we see that a lot of these attacks that start at the endpoint resource level, such as the pod that we saw here, and we have detections for it as well. They can escalate to compromise of the EC2 host, container escape, or privilege escalation. There are a number of findings we have for that. From there, the attacker could get hold of the EC2 instance credentials potentially, and from there get authenticated access to the account and start enumerating resources, all the way down to the S3 data plane where perhaps we'll see data exfiltration. GuardDuty will follow all these steps now, with this starting at the runtime, the EC2 level, the control plane, data plane, both for Kubernetes and for the broader AWS environment. But really in this scenario where it starts with a vulnerable application compromise or compromise of the pod itself, this runtime detection is the earliest indication. And as we can see in less than a minute, we already have that signal where you can cut that off before it gets to that broader AWS environment compromise.
Thank you, Amit, for adding this. Okay, so yeah, you can see that we got the reverse shell finding in less than a minute after the attacker created a reverse shell. And again, like all the other findings, you get all the context here as well. Here you can see that lineage is a little bit different. For the previous findings, the lineage was just 3 levels. Now it's basically 5 levels because, the reverse shell probably involved invoking more processes.
Okay, thank you, Asik, for that demo. Yeah, I think that was a great showcase, and for a lot of the reasons why we're so excited about having this out and then having this in the hands of customers to help better protect their EKS workloads. And I think with that, we're ready to sum it up. So yeah, so we hope this was useful to help you learn more about this new capability in Amazon GuardDuty. Our goal here really was to get to really the deepest levels of security and threat detection for EKS that we can in GuardDuty, while balancing that and keeping that GuardDuty user experience of making it easy to manage at scale, organization-wide, thousands of accounts, and a multitude of resources in EKS clusters and containers and pods. Keep it simple, but give the really deepest level of threat detection security. And we hope we're able to do that and help customers out. And most importantly, we want to hear about it. So we welcome feedback. We're looking forward to customers using this and hearing feedback and continuing to iterate. We're already iterating on even more advanced and new detection capabilities in this space. And we're looking forward to continue working with our customers on it. So thank you.